Hi guys, it's me, the math person. Today I'll be going over question 278 on SOA Exam P. So pause the video real quick and try this problem yourself. Okay, assume that you already attempted it. Let's just dive right in. A company has purchased a policy that will compensate for the loss of revenue due to severe weather events. The policy pays $1,000 for each severe event in a year after two such events in that year. So that just basically says after two severe events, they will pay $1,000 each after that. The number of severe weather events per year has a Poisson distribution with the mean 1. Calculate the expected amount paid to this company in 1 year. Okay, so then we know that when there is 0 severe weather, the expected amount paid to the company is just 0. When there's 1, it's also 0. When it's 2, it's also 0. And then on the third one, that's when they start paying 1,000. And the fourth one, they'll pay 2,000, and so on, right? And then we're looking for, and this we know that the probability is a Poisson distribution with the mean equal to 1, and we're looking for the expected amount paid to this company in 1 year. Okay, so let me just write this in terms of the Poisson distribution. Again, Poisson distribution formula is, this should be like our best friend by now, equals e to the negative lambda to the x over x factorial. Alrighty. So let me just write it in. So the expected amount is just equal to 1,000 times e to the negative lambda to the x over x factorial plus 2,000. Oh, this is, and we know that lambda in our case is 1. Okay, this actually 1 to the any power is just still 1, so I'm going to leave that part out. But then the denominator is 3 factorial because x is equal to 3 at that point. So then, and they will also pay $2,000 when e to the negative 1 over 4 factorial, and then so on. So at 3,000 it's going to be e to the negative 1, 5 factorial, so on. So that I think you guys can kind of see the pattern, right? So the pattern is n minus 2,000, right? Because like this is 4 and this is 2,000. N minus 2,000. Wait, I think I should say n times 1,000 minus 2,000 times e to the negative 1 over n factorial. So we're summing this up from n is equal to 3 to infinity, right? That's basically what this formula is saying, or what we can infer from the pattern that we see here. Okay, so I'm going to rewrite this as factoring out the 1,000 out. So this is equal to n equals 3 infinity n minus 2 e to the negative 1 over n factorial. Okay, so we can actually change it to 1,000 starting from n equals 0 infinity, because when we find Poisson distributions, it's better for us to start it from 0, because then we can use the definition of a Poisson distribution and Poisson expectations. So, and we're allowed to do that because from 0 to 2, it is just arbitrary 0. So by shifting from 3 to 0, we're adding just the expectation of zeros. So we're just adding 0 plus 0 plus 0, which really doesn't change our equation. So that's why we're allowed to continue with that process right here. But then another problem occurs is that then this makes it so it's at 2, the value at 2 is 0. And we know that's not technically true, because if it's saying, because we shifted over by 3, so it's saying that the value at 5 is technically equal to 0, which we know is not true. So to avoid this, to combat this problem, what we're going to do is we're going to go from 0 to infinity minus the 0 to 2 part, so we get what we want, which is this part right here. So that's what we're going to do. So we're going to go from 1,000, going from 0 to infinity of this function right here, minus the going from n equals 0 to 2, just so we can combat that problem that we had. Okay, And this way we know what this is. We know that this is just equal to 1000. I'm going to split this up into 2. So I'm going to say this is n e to the negative 1 over n factorial plus, this is a big 1000 is on the outside, plus going from n equal to 0, e to the negative 1 over n factorial times 2. Oh, this is minus, by the way. Okay. And this is just equal to minus this part, n minus 2 e to negative 1 over n factorial. Okay, so we know what this is. We actually know what this is. This, we know our Poisson distribution is given right here, right? E to negative 1 times x factorial. So in our case, we're just using n factorial, right? E to negative 1 over n factorial. When we just multiply by n and we're summing it up from 0 to infinity, well, that's just the expectation of a Poisson distribution, right? And we know that the Poisson distribution, the expectation is equal to lambda. And our lambda in our case is 1. So then we know that this value right here, 1000, times this value right here is 1. And then this part right here is summing up all the possible probabilities from 0 to infinity. Well, we know all probabilities have to add up to 1. So then because of that, this is just a negative 2 times 1. So this is minus 2 right here. And then we're figuring out this part. This part, since this is discrete and it's not, because this is finite, we can actually easily figure this out by just plugging it in. So if I plug in, let's say n equals 0, then we get negative 2 e to negative 1 over 0 factorial, which is just 1, plus, if, for example, let's say n is equal to 1, then we get 1 minus 2, which is negative 1, e to negative 1 over 1 factorial, which is just 1. If n is equal to 2, well, 2 minus 2 is just 0, so 0 times anything is just 0, so that's what we get. So when we simplify this, we get 1000 times 1 minus 2, which is just negative 1, minus, there's 2 negative signs, right? Or this part right here is equal to negative 3 e to negative 1. So 2 negative signs make a positive, positive 3 e to negative 1. So this is equal to 103.638, which is approximately equal to 104, which is our answer B. If you guys have any questions, feel free to leave them down below. Otherwise, make sure you like, subscribe, and share. Bye!